Let us move on to chapter number 2, which one is very important from the examination point of view as well as study of finite element analysis. I would say this is the chapter is a gateway of the finite element analysis. In a chapter number 1, you are finding the different types of the approaches and the processes to solve the finite element problems. But the chapter number 2 is very important from the all aspects. In this chapter, you need to learn a lot of things. This is the chapter unit number 2, where you need to do the study of the 1D elements, that is the one dimensional elements. In this one, you need to find out first of all what are the different types of the 1D element. A displacement function, this is also called which one is playing a very important role in the finite element solution. Then you need to focus on the different types of the coordinate system. There are the different types of the coordinate system: a local coordinate system, global coordinate system, and the natural coordinate system. These all coordinate system we need to learn into this chapter, and the concept of this coordinate system playing the very vital role in throughout the finite element analysis. If we are not understanding the coordinate system in a right way, we could not be able to solve the problems of the finite element analysis. So we need to learn the global, local as well as the natural coordinate system, which are very helpful for solving the shape function. The third parameter is the polynomial form of the interpolation function. This interpolation functions are sometimes also called as the shape function, and this is the polynomial form. We use many types of the forms into an interpolation function. So in a polynomial form, we need to do the study of a linear polynomial, quadratic polynomial, and the cubic polynomial interpolation function. So when we are considering the linear polynomial function, that time we are considering a linear relationship between these one. But when the number of nodes into a discretization process are increases, then we need to go for the quadratic equations. And when we have seen a curvature, that time we need to go for the cubic type of the interpolation functions for the of a polynomial forms. So this is also the very important parameter into the finite element analysis. Similarly, here we need to do the study of the properties of the shape function. Now here we need to do the study of a shape function, but we are not defining or we are not calculating the shape function in this chapter. We keep these shape functions to be derived in a chapter number 4, where this plays the very important role. But I observed sometimes in the examination they are asking some questions on a shape function in a chapter number 2 also, but we will not spend a lot time on a shape function in unit number 2. Otherwise we could not be cover the unit 2 very fastly, because I need to feel that once we are understanding the basic philosophy of the how to solve the problem of a finite element analysis, then we are moving on the properties of the shape function. Lastly, we are need to do the study of the primary and the secondary variable. Here we need to, this is the very important concepts: formulation of the element stiffness matrix and the load vector for the bar, truss, and the beam using any approach. Here we are using the direct stiffness method for calculating or for formulating the element stiffness matrix for the bar, truss, or the beam. Then we need to formulate the load vector, or we need to find out the solution for the temperature or the heat transfer only for the bar. And finally we need to go for the assembly of the global stiffness matrix, a load vector, properties of the stiffness matrix, half bandwidth, temperature, treatment of the boundary condition, that is the elimination approach or the penalty approach. Also we need to do the study into this one, and the stress and strain reaction force calculation. In a nutshell, I would say that this is a very big chapter where we need to spend a lot of time just to understand the many parameter, many concept, and the many things about the finite element analysis. So dear friends, be alert in a chapter number 2. If you are learning, understanding chapter number 2 in a right way, then definitely you will be able to solve all problems in chapter number 3, 4, 5, and 6. Otherwise you could not be comfortable with the finite element analysis. Let us move on. What are the different types of the elements are available in a finite element analysis. Now word is already there, that is the finite element analysis. Whenever we are looking towards any object, it is the continuum. So we could say that there are the infinite number of the atoms and the molecules are atoms and the atoms available into a element. So this is the infinity problem. So what we have done, we have discretizing, we are categorizing the total figure into a small parts, that is called as the elements. And these elements are of three types. One first element is called as the one dimensional element, two dimensional element, and the three dimensional element. In a finite element analysis, we have considering one dimensional problems, and in that one dimensional problems we are considering a line. So element type is a line, and the different types of the elements types are the rod, bar, beam, pipe, etc. All that will not be considered. These are used into shafts, beams, pin joints, etc. And like this one. So if we are looking towards this one, this diagram, here you could see two nodes, node 1 and node 2, while here there is a displacement along the x-axis. So this is called as the linear element. Now the higher order elements that has three nodes. Now here you can see that this is the node 1, node 2, and the in between these three third node is available, and the elongation or the displacement taken place along the x-axis. That's why this is the 1D problem, but this is also called as the quadratic element. And the third one is the cubic element. Now see here, this one is the curvature, and this curvature is to be considered with the help of the four nodes. So node 1, node 2, node 3, and node 4. So such type of the elements are called as the one dimensional cubic element. Now this is the two-dimensional element. In this two-dimensional element, the element types is a triangular or the quadratical one. Now this is the triangular or the quadratic one. At the every end there is a node 1, node 2, node 3. So at the end of this triangle or the quadrilateral, there are the nodes are available. Again, this one is the type is the shell, plate, or the plate stress. All these parameters are considered into this one. This one are to be applied to the sheet metal, plastic components. It is all that one. We could see here there is the certain triangular element with the more number of nodes. Here the nodes are not at the corner of the points, but in between also we have seen the certain nodes. So according to that also we would be able to define a different types of the element. The detailed study of this one we are doing in the next chapters. Here only we are considering the concept about the elements. Now the different types of the nodes, whatever the nodes we need to do, and the degree of freedom, because this is very important. Nodes, now there are the two types of the nodes. Now here before that one, just we have already studied the elements types in the element type 1 for 1D, 2D, and here there is a 3D element. 3D element looks like this one. Now the element types are the tetrahedral or the hexahedral, and the element types is the solid one. We could see here also the nodes are available at the each corner, each corner of the triangular figure, or we could say this is the tetrahedral or the hexahedral. Here these one are used in many components. These are useful for the atom oil as well as the aerospace component, or the forging, casting components, where the study are very important. But whenever we are dealing with the three-dimensional elements, that time we are facing a lot difficulties and a lot issues to manipulate the matrices. And when we are going for the three-dimensional matrix manipulation, it takes a lot time, so that there is a need of the computers programs or the computers, and hence finite element analysis getting the more importance or the more popular because of the computer facilities available nowadays. Now there are the types of the nodes. There are the types of the nodes. There are the two types of the nodes. One is called as the internal and the external nodes. So these one are the internal nodes, and these one are the external nodes. Those who are at the end of the element, that is called as the external nodes, and the internal node in between these two nodes. And this is the internal node as well as this is the external node. And lastly, this is the very important parameter, that is the DOF or the degree of freedom. Degree of freedom, you knows very well. I have already explained in a chapter, in a unit number 1, a degree of freedom. Now what is that degree of freedom? Now if I take this node 1 or this element, now this element if elongated into this direction, and if we have considered this is the y direction, then we could say that there is the one direction degree of freedom of a node on a node. So we need to focus first of all on a node, and on this node how many movements are possible, that movements are called as the degree of freedom. So there is a possibility this node may move in this direction, this node may move in this direction, or this direction, then xyz movement. So if there are this xyz movements are possible, then that is called as the three DOF. Now if these nodes are also rotating along x-axis, also rotating in a clockwise direction along the y-axis, as well as the clockwise direction into the y-axis. So along the x-axis, whatever the displacement and the rotation 3, so around means at every axis there are the 3 rotary motions as well as 3 linear motions. So there are the 6 DOF, as well as if that there is the anti-clockwise movement also possible, then there is the addition of a 3, so there are the 9 DOF we can see into at a one node. But whenever we are going for the more number of the DOF, then my matrix is a very bigger one, and it is very difficult to solve that one. So generally we need to keep a very focus on a DOF, that what type of the DOF or what is mean by the DOF. I hope through this presentation we understand a very simple things are, first of all, what is mean by the element. Element is a 1D, 2D or 3D. In a 1D we say take a very simple line. In a 2D we have taken the triangular or the rectangular one, and in 3D we have taken the rhombic, that is called as the tetrahedral or the hexahedral elements for the study. And the nodes, two types, internal and the external, as well as the DOF, that is the degree of freedom at the nodes, whatever the movements are possible, that is called as the DOF. I hope you understand all this concept very perfectly, and let me move on the next lecture. Thank you for the watching.